All right, today we're going to move into lesson 9.8 on the law of cosines. We're going to apply the law of cosines to some application questions to find a missing side length or to find a missing angle measure. All right, here's what the law of cosines looks like. And we can use these in any triangle. It doesn't have to be a right triangle, these law of cosines. And we can either find it the third side when we know two of the sides and one of the angles, or we can find an angle if we know all three side lengths. Okay, and the law of cosines looks like this. If we have triangle ABC, where A, B, and C are side lengths opposite the angles A, B, and C, all right, based on this triangle, then the law of cosines can look three different ways. This way, A squared equals B squared plus C squared minus 2 times B times C times the cosine of A. That's one of the law of cosines. A second one would be if the B was here, B squared equals, and then you got A squared plus C squared minus 2AC times the cosine of B. And the third version is when the C is over here. So it's C squared equals A squared plus B squared minus 2AB times the cosine of C. So notice whatever side length is isolated here, its angle is used in the cosine function. Now, these all three are different, but it all depends upon the two sides you were given and how you name your triangle. But the concept for each one of these is the same. You're going to want to have these handy as we choose one to apply to the situation. So let's look at an example. So we got two airplanes that are leaving the airport here, and they're going in two different directions. In an hour, one of them flies, or actually, let me go back to the way it's written. After an hour, they are 295 kilometers apart. That's this distance. Okay. One plane has traveled 296 kilometers from the airport. The other is 224 kilometers from the airport. And they are, like I said, 295 kilometers apart. They want us to find the angle between their paths. Okay. So the first thing I want to do is take the triangle and I want to label it so that we can tell what's what. So I'm going to call the airport point A of my triangle. So this is vertex A. That's going to make this side the opposite side, which is the distance between the plane. That's going to make that the lowercase a. That's the side across from angle A. And then whichever one of these two you want to name B and C, it won't affect the outcome. So I'm going to call this plane down here, its vertex is B. That makes this side opposite lowercase b, side length B. This plane I'm going to call C. This opposite side then is the lowercase c, representing the length of this side. So by doing that, I'm very clear on what point we're looking for and how we're trying to solve this. Now, we're trying to find angle A. So that means I want to use the law of cosines function that had cosine of A in it. And that's the one that looked like this. A squared equals B squared plus C squared minus 2BC times the cosine of A. I want the cosine of A because I'm trying to find angle A. Okay. If I would have been trying to find angle B, then I would have chose the one that had a B squared over here and cosine of B in it. It all depends upon how you want to set it up as to what we're looking for. In this case, I want to find angle A. So I'm looking for cosine A. All right. So what we're going to do is we're going to plug in the values that we have. So we know that this lowercase a is 295. We're going to square that. The B is 224. The C is 296. So I'm putting those in the places of the B and the C here. And then notice it's 2 times BC. So that's 2 times 224 times 296 times the cosine of A. So this really is just substitution. That's all we've done is plug everything in. Okay. The next thing, or at this point, all we're doing is solving this equation. So we'll start with squaring all of these and multiplying these together. What that would do, if I do 295 squared, I'm going to get 87,025. 224 squared is 50,176. 296 squared is 87,616. If I multiply these three together, I get 132,608 times the cosine of A. Now that's a minus sign right there. That's a plus sign, obviously. All right, so these are three separate terms over here. Okay. As I look at this, these two are like terms because they're numbers. This one has the cosine of A attached to it, so it's not a like term to these two. So I'm going to add these two together next to give me 137,792. All right. At this point, I want to isolate cosine A. I'm trying to find angle A, which I have to isolate cosine A to do that. So think of this just like as an X right here, and I was trying to solve for X. The first thing I would want to do is eliminate this number. So I'm going to subtract 137,792 from both sides of this equation. Okay, 87,025 minus 137,792 will give me a negative 50,767. Okay, now that is equal to this. Make that minus sign stays here. So it's negative 132,608 times the cosine of A here. At this point, we want to isolate cosine of A. It's being multiplied by this negative number. So we're going to divide each side by that negative number. Okay, this number will cancel out this one. That gives me cosine of A. Now here, because I know what I need to do coming down the road, I'm not going to divide this out and make it into a decimal. All I'm going to do is recognize that this is now positive because a negative divided by a negative, this is now a positive number. Okay, now I have the cosine of A equals this, and I just wrote it as a fraction. We want to find out what A is. Well, to find out what A is, we got to eliminate the cosine. What eliminates cosine is cosine inverse. So the cosine inverse of the cosine of A will cancel that out and give me angle A. Cosine inverse of this number will give you your answer. So I go cosine inverse, I put parentheses, 50,767 divided by 132,608, close parentheses, hit equals, and you should get a 67.5 degree angle. So the measure of the angle between these two flight paths would have to be 67.5 degrees in order for this problem to work out the way it does. Okay. Now, once you solve a couple of these, you're going to see the process is pretty consistent as to how we go through the solving deal. There's really two different ways we can do it, and I'll show you the second one here next. Okay, but that's an application of the law of cosines. It's just a formula. You're going to plug in numbers. You're going to solve for the unknown. Okay, let's look at another one. So we got Billy flying two kites. He's got 99 feet of string out on one kite. That's this one. We got 114 feet of string out on this one. And the angle formed by the two strings is 27 degrees. We're asked to find the distance between these two kites. Okay, so again, what I want to do is let's label some points here so we can tell what's what. So again, I'm going to call where this Billy's standing here. That's point A. Okay, this distance between these two kites is the third side of my triangle. That distance is lowercase a. That's what I'm trying to find. What is this length right here? Okay, now again, these two are B and C, however you want to name them. So I call this angle or this vertex B. That makes this the lowercase b, side length B. This kite is C. That makes this distance the lowercase c, the distance here. Okay, now we're trying to find the A. Okay, we're trying to find the length of side A. So again, I'm going to choose the equation or the law of cosines function that has the A, lowercase a, already isolated, which is this one. A squared equals B squared plus C squared minus 2BC times the cosine of A. So there we go. We're going to use that one. Now, we're going to plug in what we know. So we know B is 114. That's going to go there. We know C is 99. That's going to go there. B again is 114. C again is 99. And then it's going to be the cosine of A, which in this case is 27. So we're going to have cosine 27. So we'll substitute all that in. Okay. The A is what we're trying to solve for. So I like it over here by itself. We'll get to dealing with that square in a second. Let's simplify all this stuff. So square the 114, square the 99, multiply these three together, and we'll have something that looks like this. 12,996 plus 9,801 minus 22,572 times the cosine of 27. Okay, So that's all simplified. What else can we do to simplify? Well, we can add these two together. Okay, this is not a like term to these two because it has this cosine of 27 multiplied by it. But we can add these two together. So adding these two, we'll get 22,797. Now at this point, I'm going to isolate my a. I don't want to have to multiply by I don't want to find the cosine of 27, multiply it by this number, and then subtract that from the 22,797 and solve it that way. I'm going to do all of these calculations at once. So what we know is we want to find out what a is. A is being squared. The inverse of squaring is to take the square root. So I'm just going to take the square root of both sides. I know the square root of a squared is a. That'll be my answer. So what I'm going to do now is I'm gonna do all of this once in my calculator. I'm going to do the square root of parenthesis 22,797 minus 22,572 times the cosine of 27 and parentheses. I think you need 2 at the end of that to enclose it correctly. And then hit equals, and you should get your answer all at once. Okay, this is the most accurate answer we can get. So we now know that the distance between these kites has to be 51.8 feet. Okay, based on our measurements here using the law of cosines. So you'll get this process quite a bit. You'll get used to solving this. Doing this all at once in a calculator, I think, is extremely valuable because you're not trying to round and look for rounding errors as they increase over the use of the problem. So we just do it all at once. Last example, pretty much the same as the kite here. But Amanda wants to know the length of the tunnel that's built through this mountain. So there's a road here and the tunnel's going through this mountain. To do so, she makes measurements in this figure below. She doesn't know the distance of this tunnel in the mountain. She knows that she's standing here and it's an 83-degree angle between one opening of the tunnel and the other opening of the tunnel. And the distance to this opening is 105 and the distance to this opening is 295. And we want to find that length. Well, again, we're going to start in the same place. Let's label this and understand what all the parts are first. So I'm going to call her, Amanda here, is at point A. That makes the tunnel distance the lowercase a. Now, the other vertices are B and C. And again, it doesn't matter how you name them. So B is here. That means I'm going to call this 105, lowercase b. This vertex is C, so its side opposite is the 295, so that's the lowercase c. So we have all the values now to be able to plug in. We just need to use the right formula, and it's going to be the same one we used last time. I'm going to choose the one that I'm trying to find A, so I'm going to choose the one that already has the A isolated, so we're already here by itself. All I got to do is these computations, take the square root at the end, and we got it. So let's go ahead now and do the computation. So I'm going to replace the B, this B, and that B with 105. And I'm going to replace this C and this C with 295. This A, cosine of A, remember that's an angle right there, is the 83 degrees. So if I do all my substitutions, it looks like this. Okay, write it out. Now, square 105, square 295, multiply 105 and 295 together. You'll get a line that looks like this. Okay, I can simplify these two. They're like terms, so I'm going to add the 11,025 and the 67,081. I'm going to add those two together. And I'm not going to do all this computation right now. I'm going to go ahead and complete my next step, which is to isolate the A. I'm going to take the square root of both sides. The square root cancels the square. I have A now on the left, which is what we're solving for. I'm going to do all of this at once in a calculator. Okay, so the square root of, and put parentheses, 78,106 minus 54,390 times cosine 83, close parenthesis, hit equals, and you should get 276.4. So the length of this tunnel is 276.4 feet. That's how far we are here for A, which is the length of the tunnel. So that's the law of cosines. Have those three different versions of this available to you, and then use the version that fits best. Okay. So we use the law of cosines tonight. I gave you not too awful many questions. They're all application questions using this. So have those handy, pull them out, write down the work, and I think you'll do good with this process.